Welcome to another video on my RaspberryPi 1 with an ADC, analog to digital converter, and two LDRs, fischertechnik LDR photo resistor, and an ordinary one, and let me use my mouse, an NTC thermistor, negative temperature coefficient thermistor, and lately it has shown not to work quite well, and if I show this, nothing actually works anymore. Now and then I get some value, but more often I get nothing. And I wondered why the NTC hasn't done anything, but lately I have done some research and found out why. And let me show you right here. This is, if you have seen my previous episodes, then you know the schematics. These are the LDRs, photoresistors, potmeter. Now it is channel 0 and 1 to the ADC, straight to the GPIO of the SPI, according to SPI protocol to Raspberry Pi. And then an LED which only goes on if this one is turned open fully, which is not the intention. But the NTC, turns out, it has to be connected to the power with potmeter, and then here to channel 2. Now I also have done this circuit, which so far hasn't done anything yet, but I am going to change the setup a bit. Well, not in schematics, but in real wiring, because it turns out that I have to rewire just a little bit using this physical potmeter, which will be then this potmeter, and then I'll have to set up this again, but that's for later. So turning back here, it will be a bit hard to see. I do acknowledge that, I do admit that, but when I bend over these, take away the mouse a bit, then this is the NTC, and what I have to do is using this potmeter, which was for the resistor, and I am taking this one out now, for now, taking this one out for now, then the NTC from, let's say, here to here, but then this wire from here to here, and that's exactly what it is supposed to be. So this resistor goes out, if it lets me, yes, and these go out as well because they are now wrongly connected. And this one doesn't mean anything right now. So I have now one potmeter, and I better show it like this. One potmeter, power to the other side of the NTC, one side, other side. So this should be alright. So now it is exactly like this schematics show. One end of the potmeter connecting to this side of the NTC and connecting to channel 2, and the other end is just connecting to ground, which also means that, let me go back, that I have to set up this again with another potmeter. So physically this one has become this one. Now another point is of course that I already have one potmeter here from other uses. So although I selected another small one, I can just as well use this one and see how this works out. So let's check the software for now. And unfortunately I do not expect to see anything different, but you never know. Nope, all quiet except for the pulse width modulation. Everything is dead quiet. And of course I am not liking this at all, so I'm getting more and more convinced that the ADC has gone, but I have not yet found a convincing way to actually test that it is really gone. Right. Now this is connected nicely. I have to connect this once again. To measure something. Now this one is already there. No point in changing that. This wire has to be there. Now let's check that it is indeed that wire. Yes. So it's this LED and this LED. Am I pointing correctly? This one. So going back again. I need to connect this right through here into some resistor. And this resistor has to go to the to ground as well. So let me see how I can accomplish that. First of all, one here. That's not such a problem. but I should start actually with this one and taking the exact middle. So I have to take this one out now. So this is like, oops, I have to get rid of this one. I'm busy here. So right now I have connected the jump wire from the middle of here to here, which is the same thing as I did here. So in the same way I have to connect a resistor like this, which I have here to connect to ground, and from here, let me indeed use this wire again, very thin, so I have to be careful. Yeah, almost unusable, as thin as it is. And connect to the other output, and there it goes again. This is actually hardly usable, but what else can I use? The remaining fixed jump wires are actually a bit long, so let me put it hopefully taking a bit long, but I will succeed. So now I have it all wired up, and not entirely satisfactory, but well, I have to improvise. So the situation in which it is now is physically yellow wire to pin 7, which means it's the 8th pin. Then there's a very little jump wire I've used before, because it is a very thin wire here, clamped onto the board, and I have to take care that these two are bare ends of other jump wires, so I hope it works. Then of course the jump wire from the potmeter here to the same line, resistor to the other part, then here a staple, yes, once again a staple as improvisation to the ground. And now there's hoping that it actually works. So I don't have high hopes for this, unfortunately. Let's look here. So now everything has been done. Potmeter, this potmeter has turned into this one. The big one is now here with one wire straight to ground. Let's have a look. And once again, no hopes, no high hopes anyway. Let's take a look at here. No, this is 0, 1 and 7, and I have 2 as well, so I should have I should change this, because this one is 2 and LDR channel, there are the LDRs are on 1 and 2, 0 and 1, then 2 for the NTC and 7 for the resistor. Oh yeah, I already had that. Wait, before turning into a real mess, right, then I will have to change this as well. Then we have LDR value, that, and yes, that one as well. LDR value 2. Then let's print, align, NTC channel and resistor channel. However, I still have to do this as well. Yes. So LDR value 2, NTC and resistor value. And that should work. Should. So, another attempt. What do I see? LDR value 2, NTC and resistor. Yeah. Let me get this one out. Just cosmetics and LDR value 1, 2. Just between the resistor and no LDR value dash NTC. Yeah. Alright. Just cosmetics, but cosmetics can be important as well. Alright. And they show nothing at all. The oscilloscope lines are also that quiet. So, apart from the pulse width modulation circuit that has nothing to do with the ADC, it looks like it's gone, totally gone. That said, what I can do still is mess with the potmeter settings a bit. So run and I see absolutely no change whatsoever. And unfortunately I can't do the same thing with this on this one. But it's giving 0 anyway. And let me once again try here. And this one is not as stable, but let me try anyway. Well, now the LED is burning, but in value it's absolutely nothing. So it does make contact. So then the question is, if I put an LED in between here somewhere, what happens? I'm afraid nothing would happen. I can measure things, but even then, what does it mean? Because without these, without the ADC working at all, I'm clueless. I'm without anything. So, what to do next? Good question. According to a website that I found on the Raspberry Pi troubleshooting with analog digital converter, they say that I have to directly connect these two together, so unlock from the wiring, then with a resistor in between, and that should directly give an impression if it works or not. So back here, and that is nothing I can show on the schematics like this, because it is on this side of the whole schematics. Anyway, I have to disconnect this wire for now, and this wire, put a 1K resistor, and that should immediately work. And to be honest, I do see something. Yes. You got to be kidding me. It does work. Let me change time base. So why don't I see anything? Anyway, I get values, and this is no use because it's locked in between. Alright, so if I take them out again, take this out again, and I put the wiring back in, what will happen? Will it suddenly start working? I don't have too many hopes, but that's a no. Would that mean that I have actually incorrect wiring? No, that is impossible, because it did work. Other question, apart from these, why don't I get anything here? I have here clock, I have data. Data, if I look here, data out is 12. If I look right here on this part, 12 is this wire, and that is this probe, blue, and blue is this wire, this line. So if I disconnect them again, this resistor once again, running again. So why don't I get the value now? Isn't that strange? I get 1023, now I get 0. All zeros. Not getting it. Not at all. Well, rounding up. for this episode at least. Oh, by the way, for some reason the Raspberry Pi did reboot again. Well, once, but that's something different. Why does one time using a resistor work nicely with 1023 value and now it doesn't? Did I then completely ruin the whole thing? You would almost start thinking so. This one right here, this one should be right there. And it's all quiet. One mystery with it. Which is the end of this episode. Thank you for watching. Well, what did I do? Rewire the NTC, rewire the resistor, some recoding, adding a channel, and test the ADC by putting a 1K resistor in between MISO and MOSI. Master input, slave output, master output, slave input. And work once. If you like this video, please subscribe to my channel if you haven't done so, and like the video. Follow me on Twitter and retweet and like, and follow me on Instagram and like. Please donate to keep the videos coming your way. See for more information, please, my website. Very much appreciated. And oh, this is going to be continued, obviously. So this is in full working order. Well, it is wired, let me put it that way. It's wired. And that's it. Bye bye.